Hello everyone, Assalamualaikum. My name is Haliza binti yusof and my metric number is 188985. Today I will present about the effect of moisture content on the strength of the peat block. This is my overview entire for my project which start with introduction, problem statement, objective, methodology, result and discussion and also conclusions. For introductions, urban farming. According to R. Hishman's 2019 stated in 2018, Malaysia's urban population was about 24.4 million. Urban population in Malaysia was increasing year by year. The urban farming is to create an abundance of food for people in need by supporting and encouraging the establishments of gardens on unused land and space while increasing diversity. There are many types of agriculture practices in urban farming, which are horticulture, aquaculture, and hydroponic that can improve urban food security. Horticulture is a plant agriculture mainly for food, materials, and ornamental. For the peat blocks are used in large-scale horticulture in Europe and are gaining popularity, quick for seed germination and seedling growth. It was made of lightly compressed potting soil that stand alone without any support holding their form. The advantages is it can be easy to transplant seedling without injuring its roots, promote great air, and biodegradable. Peat blocker is a tool that produces peat block that can be used for seed plantings. This figure 1 is the peat blocker and figure 2 is the soil block, which is peat block. For the problem statements, urban farmer usually have a problem with the peat block structure that can easily break apart when having excess water, and also the soil mixture of the peat block is not ideal. So the best solution for the urban farmer is to find the best mixture of formation composition for the peat block. It's also the suitable and also to find the suitable moisture content on the strength for the peat block. Okay, this is the objective. The aim of this study was to investigate the effect of moisture content on the strength for the peat block developed using different mixing ratio of soil, growing media, fertilizer, and water. First objective is to determine the best mixture of formation composition for the peat block structure using different mixing ratio. And second is to determine the moisture content to break apart the peat block. This is the methodology. For the first is flowchart of the experiment. We start with materials preparations, production of peat blocker, and goes to experiment 1. The peat block were developed by using peat blocker with different mixing ratio of soil, growing media, fertilizer, and water, and the best mixing ratio samples were selected and dried in 2 days. After that, experiment 2, which is the mixing ratio samples, were sprayed at interval 10 seconds with 10 milliliter of water until the peat break apart. From that, the best moisture content to break apart the peat block was selected. Then the data was analyzed by using ANOVA. For the experimental methods, with peat blocker productions, with using plywood materials, nails, hammer, super glue, saw, and plastic to develop a peat blocker. For the size of the peat block is 5 times 5 times 5 centimeter, which is volume of the peat block is 125 centimeter per cube. The blocker was fabricated with thick compartments of peat block, and it was wrapped with plastic to avoid friction. Okay, this is the figure 3, the peat blocker structure with 5 centimeter thickness, width and height. For experiment 1, is to determine the best mixture of formation composition for the block structure using different mixing ratio of soil growing media, fertilizer and water. From figure 4, show the flowchart of the pH value. Start with the weight and mix the soil, growing media, fertilizer and water, and measure the pH value. If the pH value is lower than 6 and higher than 8, it should repeat until the pH value, until the mixture of the formation of the peat block is the pH value is the within 6 to 8. After that, go to experiment 1. 162 of peat block were prepared. The samples are divided into two major groups, which are rice husk ash, which is 84 samples, and same goes to raw rice husk with 84 samples too. Also, samples are compressed with peat blocker and dried into 2 days. Sturdy peat block structure was selected to treat at experiment 2. This is the table 1, the mixing ratio of rice husk ash growing media data. This is from the soil, rice husk ash, fertilizer, water, and sample name. We start with control A11 to C33. And same goes to the raw rice husk growing media. With D11, start with sample name D11 to F33. After that, from the experiment 1, observation of the peat block is in a 3 category, which are less sturdy, sturdy, and clumsy. This is figure 5 shows that less sturdy peat block structure, for figure 6 sturdy peat block structure, and clumsy peat block structure. Experiment 2, to determine the effect of moisture content to break apart the peat block. Each block was sprayed with water at interval 10 seconds with 10 mm of water until the peat was break apart. The figure 8 shows just how to spray the peat block. Data analysis using ANOVA and the P to determine the P value and F value. This is a result and discussion. From table 3 below shows that the observation of sturdy structure with different mixing ratio. We know that volume treatment is using 30 milliliter. As well, 30 milliliter will make the structure of the peat block sturdy. And for the table 4 shows that the structure of the peat block is less sturdy with volume of water with 20 milliliter. And for table 5, the structure of the peat block is clumsy because of the volume treatment is 40 milliliter added to the mixing ratio. The structure of the peat block before and after the experiment 2. From figure 12 is the before spray and after spray with water. The maximum and minimum of the time taken and amount of water of peat block to break apart. From the bar chart below, we know that 160 seconds, which is sample D12, which are using the raw rice husk as a growing media, and the minimum time taken and volume of water is 126.67 seconds and milliliter of water, which is the rice husk ash sample. Okay, data analysis using ANOVA. From table 6 below, media treatment is with time taken of the peat block to break apart. From the ANOVA, we have only focused on F value and PR. For table 7 shows that the result of media treatment with volume of water, F value and PR with 10.73 and 0.004. The analysis using ANOVA is table 8. Also, fertilizer with volume of water, and table 9 with fertilizer with time taken. From all the table 6 to table 9 shows that analysis is media treatments give significance to time taken to break apart the structure of the peat block because of the value of the PR is lower than F. For medium treatment gives significance to volume of water to break apart the structure of the peat block 2 because of the PR value is lower than F. Table 8, fertilizer gives not significant to time taken to break apart the structure of the peat block because PR have higher value of F, higher value than F. And same goes to table 9, fertilizer give not significant to volume of water to break apart the structure of the peat block because of the higher value of PR. As conclusion, the best mixture of formation compositions for the peat block structures using different mixing ratio was determined. The sturdiest structure of the peat block is using 30 milliliter of water added into the mixture compositions. The volume of water is very important because it can affect the whole of the structure. The moisture content to break apart the peat block was determined. The first is the best mixture moisture content and volume of water to break apart the structure of the peat block is 162nd with 160 milliliter of water and using raw rice husk as growing media to strengthen the strength of the peat. From the significance of the strength of the peat block by using ANOVA is determined. Media treatments give significance to time taken and volume of water to break apart the structure of the peat block, and also the amount of fertilizer was not affected to the structure of the peat block with time taken and volume of water. That's all for me. Thank you.